Hello, everyone. Thank you for joining us. Welcome to the Understanding the Post-Disaster Buildings Material Crisis seminar series. We're delighted that you're able to join us. We are going to get started while people sign in. For those of you who are able, please go ahead and put if you wish, your name and your affiliation and where you're calling in from in the chat so we know who is in the virtual room with us. Next slide. So my name is Anita van Breda. I'm the Senior Director for Environment and Disaster Management at World Wildlife Fund. I will be your moderator today. Apologies to those who are up very early or very late. We are trying to find a time that could accommodate a global audience. I want to welcome and thank our colleagues and panelists who are joining us here today. This has been a joint effort, and we're very excited to kick off this seminar series with our colleagues from Northwestern University, RMIT in Australia, and UNOPS. I'd also like to thank Senia Dubova and Hashan, who are on the EDM team here in Washington, D.C., and our senior support expert, Kasia Patka. So in the interest of saving time, we are not going to go into the details of everyone's biographies. You have them in the seminar invitation, and we are going to try to stick to time so we can get through a packed agenda. Next slide, please. So we're going to have a bit of an overview of the Environment and Disaster Management Program and some opening remarks from our colleagues at UNOPS. Then we have three panelist speakers. We're going to share with you an online survey that you can do at your leisure, and then allow some time for question and answer before we wrap up. So that is our agenda for today. Next slide. This is part of our continuing education seminar series. We would love to hear from anyone who has recommendations for either topics or speakers. We'll give you our contact information at the end, and we welcome your thoughts as to future topics. Next slide. For those of you not familiar with the Environment and Disaster Management Program at WWF, our goal is a simple one. It's reducing risk and vulnerability for people by working with nature instead of against it. We work at the intersection of disaster management, environmental management, and development, and place that work to the extent possible in climate mitigation as well as adaptation. Next slide. We've been doing this work for over 20 years now, responding to various events around the world, and we use our tools and techniques to support recovery and reconstruction as well as risk reduction. Next slide. So our work is organized primarily into three work streams: our green recovery and risk reduction program, our nature-based flood management program, and our infrastructure work, where the building materials that we're talking about today is focused. Most of our tools are free and open source and available in multiple language, and we do provide training to support the use of those tools. Next slide. This work that we're talking about today was born out of the 2015 Nepal earthquake, where my colleague Missaka worked with colleagues in Nepal to develop the Building Material Environmental Guide, or BMEG. Then a few years later, we worked with Northwestern University School of Engineering to expand that guide. There have been a few local versions that have been developed for specific countries, and that has led us to this call to action report today that we're sharing with you today. Next slide. So this is the first in a three-part webinar series. We hope that you will join us for webinar 2 and 3 as well. And with that very short background and overview, I'm going to invite my colleague Stephen Crosskey from UNOPS to kick us off with a few opening remarks. Stephen, thank you very much for joining us, and the floor is yours.
Thank you so much, Anita, and a real pleasure to be here on this important topic. I really want to thank our colleagues at the World Wildlife Fund, Northwestern University, and RMIT University for leading the global call to action on sustainable building materials management in post-disaster situations, for organising this webinar. I'm really looking forward to sitting in on this and listening in, and also the following 2 webinars. After disasters and conflicts, there's an immense pressure to rebuild as quickly as possible. To replace hundreds of thousands of damaged structures, we need millions of tons of construction materials. Supply chain disruptions, sanctions, inflation can make these construction materials 30 to 120% more expensive. Disrupted regulatory procedures can lead to a poor quality of materials being produced as communities try to meet surging demand. This leads to delayed or low quality reconstruction, and it keeps people vulnerable to further negative impacts. Some fall into long-term debt trying to purchase materials to reconstruct their homes. Some end up living in makeshift or inadequate structures that are physically unsafe. And the massive demand for materials leads to over-extraction and environmental damage that can increase the risk of future disasters. So how do we prevent a vicious cycle from happening where disasters and conflicts lead to more vulnerability and risk for communities? From our implementers' perspective, we at UNOPS see that humanitarian response can be supported by investment in a more sustainable, resilient, and inclusive construction sector. Take, for example, the option of recycling disaster rubble for reconstruction. Our latest report, From Rubble to Resources, estimates that recycling disaster rubble to produce reconstruction materials can be up to 49% cheaper than landfilling the rubble and buying the same amount of new materials. This process creates jobs and business opportunities for the local community, and it mitigates the environmental damage caused by quarrying. However, if recycled and circular materials are not recognised in existing construction policies and standards, they will not be chosen by architects, engineers, and buildings after a disaster. If construction and demolition waste management has not been normalised through governance and regulations, it can seem more obvious to landfill rubble instead of recycling it. Policies, standards, governance, and regulations can create an enabling environment that supports the implementation of sustainable and equitable reconstruction in complex post-disaster and post-conflict settings. These can enable a people-centered circular rubble management and reconstruction approach. And that is outlined in our latest report, From Rubble to Resources, and we will discuss more in the next webinar. And I really look forward to hearing from our next speakers on this really important issue, and thank you for giving me the time to speak. Back to you, Anita.
Thank you so much, Steve. Really appreciate that scene setting for us. We will go on to our first panelist speaker today, Missaka Hettiarachchi, who's with WWF. Missaka, the floor is yours.
Thanks, Anita. And hello, everyone. Thanks for joining us today. Good morning, good afternoon, good evening, wherever you're joining from. I'm joining from Melbourne. So I'd like to acknowledge the traditional honors of the First Nation peoples of Australia, on whose lands we live, work, and learn. I hope my slides are visible and in this presentation mode.
Yes, you are good. Thank you.
Let me begin by taking you all to the place where I was brutally made aware of the realities of the post-disaster building materials crisis, to Sri Lanka. This stretch of beach in the western coast of Sri Lanka underwent rapid coastal erosion within just a matter of few months, as you can see in the pictures. What caused this? Indian Ocean tsunami struck in December 2004, and Sri Lanka was one of the most affected countries. Over 100,000 buildings were damaged and required to be rebuilt. This immense demand for new buildings created a demand for building materials as well, especially river sand. And this caused excessive river sand mining in some of the major river basins in the country, which is practically a small island, and caused irreversible impacts on major rivers, as you could see in the previous slide. This trend is was not limited to Sri Lanka. It is continuing in all the major disaster aftermaths, regardless of whether they are in the global north or the global south. For instance, if you take the Turkey-Syria earthquake in 2023, where 164,000 buildings were damaged, but a record volume of 100 million cubic meters of debris was generated. To put it in perspective, that is 40 times the size or volume of the largest of the Great Pyramids of Giza. In Nepal, for instance, Nepal earthquake 2015, the reconstruction required over 1 billion clay bricks. And again, to put it in perspective, if we lay those bricks in a single line, it would traverse the Earth's circumference 6 times. Now, what makes the situation worse is that even in a non-disaster context, construction industry causes a mind-boggling level of environmental and social impact. Some of those impacts and requirements for the construction industry is given in numbers here. It consumes over 40% of the total energy use or energy generation of the world, and emits again nearly 40% of the greenhouse gas emissions from all the manufacturing and industry related outputs of the world. And by 2060, it will actually extract over 90 billion tons of non-metallic minerals, especially used in the construction industry. Now, these are the concerns that brought several international organizations and academic partners together to create this global call to action to put together this. This included World Wildlife Fund, Northwestern University from the US, RMIT in Australia, and the United Nations Office for Project Services. The question that we are trying to raise through this global call to action is why sustainable building material management should be at the forefront of crisis recovery or disaster reconstruction, just not a side note. You can download this complete report from the QR code given here. Also, the link to it would be provided now in the chat. In the CTA, in this global call to action, we looked into over 20 largest disasters in 2005 and found a whole smorgasbord of issues that can be created by the problems in sourcing, use, and management of construction materials, especially poor management of construction materials in post-disaster context. This included generation of debris, price hikes, low quality of materials, over-extraction, illegal extraction of materials, and so on. We distilled these issues into 3 major categories. First, the building material shortages and price escalation that hampers or becomes a roadblock for efficient reconstruction after disasters. The environmental impacts of material extraction and use, as we saw earlier in the slides, and the unsustainable management of disaster debris, which my colleague Martin would talk about in detail in the third session. Now, it's not only these issues are extremely complex, they are spread across the disaster management cycle as well as the construction project cycle, which makes it more difficult to address them directly. But addressing the socio-environmental impacts of post-disaster reconstruction is not totally a neglected issue. These issues have been well identified, especially in the disaster management policy frameworks. As you can see, there are a number of policy and practice guidelines, even the foremost policy frameworks such as the Sendai framework and overarching guidelines such as the Sphere Handbook identifies the need for environmentally responsible use of materials, building materials, in disaster response. There are global guidelines such as the Green Recovery and Reconstruction Toolkit published by WWF as far as in 2010. There are national level guidelines such as Building Back Safe and Greener, which was published specifically for targeting Nepal after the 2015 earthquake. And the newest entrant to this suite of guidance documents is the From Rubble to Resource guideline, which UNOPS published just last week. And if you take the construction sector, there are a rich volume of guidelines, environmental guidelines available, as the two, like few that I have indicated here, like the 10-hole life cycle recommendations for building and construction, or for the buildings breakthrough, which was attained at the 2023 Climate COP. There are also many technical tools as well, such as the NEAT Plus tool and some very specific tools such as shelter methodology for carbon assessment and building materials selection and use, BMEG guideline published jointly by WWF and the Northwestern University. But there are few policy gaps that hamper post-disaster materials management. As we could see, global policy, there are many global policy advancements towards sustainable built environment. There are policy initiatives for green recovery, but there is a gaping policy disconnect between construction and disaster management sectors, which actually leads to an acute lack of disaster preparedness in the construction sector. Right, so there is a fairly reasonably good connect between construction and environmental policy, and disaster management and environmental policy, but not a good connect between construction sector and the disaster management sector. So how to address these issues? Number one, these are nuanced issues, and they have to be addressed in their particular context, and they should be placed very carefully across the disaster management cycle and the construction project management cycle, because these issues are equally distributed. The issues are equally distributed through these cycles as well. Finally, although the potential management interventions could be very diverse and has to be executed in a nuanced approach, we could bring down or narrow down the potential approaches to four major strategic recommendations. First, integrate sustainable materials management into disaster recovery policy, including the future UNDRR policy frameworks. Elevate sustainable material use as a key performance indicator for reconstruction projects, such as including them in the Sphere Handbook and other guidelines of humanitarian agencies. Develop construction sector preparedness guidelines through global regulators such as FIDIC and Global ABC and so on. There are some very rudimentary initiatives, but they have to be taken much further and advanced much further. Finally, establish a global hub for post-disaster management of building materials at a suitable institutional home. For example, the Global Shelter Cluster. Of course, the name of the cluster has changed now, but you get the idea. Before finishing, I would like to invite you and support us, further take this engagement with us a bit further and contribute to this online survey that we have created. It is just a 10 to maximum 15 minutes, most probably 10 minutes online survey to collect your perceptions and industry evidence about the global post-disaster building materials crisis to understand it better. You can access it through this QR code, and also I believe the link would be now shared in the chat. To conclude, I would like to share this thought with you. Those of us who are engaged in humanitarian responses of whatever the kind, whatever the industry that we are coming from, we hold saving lives as the paramount in paramount importance in post-disaster response and reconstruction. But let's not forget, resilient buildings and what we built with them also saves lives. Thank you.
Thank you so much, Missaka. That's great. And yes, please do avail yourselves of that survey if you wish. We will be sharing results of the survey as well as more information of future seminars and a summary of this one. So with that, I'd like to invite our next panelist, Usha Iyer-Raniga from RMIT University in Australia. Usha, the floor is yours. Thank you.
Thanks, Anita, and good evening, good morning, good afternoon, wherever you are. Can you just take it to the next slide, please? And perhaps slide number 3. I would like to pay my respects to the Woiwurrung and Boonwurrung language groups of the Kulin Nation on whose unceded lands I'm speaking to you from today. It's an acknowledgement of the 60,000-year plus history that Australian First Nations Australians have had. Missaka already talked about the impact of building and construction, so I'm not going to go through the numbers again. You've got them in front of you. But it's really critical for us to now start to think about, particularly when you look into the future, where this construction is taking place, which parts of the world are increasingly being affected by disasters, and how much goes back into the process of construction and reconstruction. So it's really, really important for us to start thinking about a different way and this big shift in how we build the materials that we build with. The next slide, thanks. So this is really where we need to move into thinking about what we have been doing up until this point in time is looking at it from the perspective of the linear economy. And so when you look at the diagram on the bottom left-hand side of the screen, you can see that in a linear economy, we have been taking things, making things, and discarding them when we don't need them anymore. In a recycling economy, we try and reuse materials as much as possible. But in a circular economy, which is the one on the far right, is where we really want to try and not have any language associated with waste. So everything is resource, and we need to design and build and use and reuse and multiple lives of building materials so that we are not having to rely on the use of virgin materials at all. On the top left-hand corner, you can say this intertwining in the linear economy between what we call as a biological cycle and the chemical cycle. When we deal with chemical cycles, it's very difficult to separate them. But when we deal with biological cycles, it is very easy for those biological cycles to become part of the planet, and then those materials could be reused again in the future. So in a circular economy, as you can see on the bottom right-hand corner in the pink, it's really about trying to maintain the value of whatever it is that we're using so that we don't have to rely on virgin materials. The next slide, thanks. And this is really, when we look at it from the context of buildings and construction, we are not just looking at the standard triple bottom line approach to sustainability. So looking at it from the social dimension, the economic dimension, and the ecological dimension. But we're also looking at governance models where we're looking at both the importance of regulatory models and legislative, but also looking at how we can bring in grassroots movements into the process. And all of this relies on us to change the way we do things from a systems perspective so that systems transformation becomes really important. Now, with the ecological dimension, we often use what is called as the R strategies. There are, in the literature, there are a number of different R strategies. It used to be reduce, reuse, recycle. So that was the 3 Rs. But when you look at it from the framework of circular economy, you actually have up to 10 Rs, 14 Rs, and so on. And essentially, as you can see on the diagram on the left-hand side, the order of priority is to try and maintain as much as possible into the green area rather than into the red area. So recycling is actually a very low order of the circular economy. And the worst, of course, is when you convert materials to energy. So incineration for energy recovery, you're forever losing the material. So what we really need to try and do is move into the highest order, which is refuse. But of course, it's going to be very difficult for us to make this big jump to refuse. So we really need to start thinking about the different steps. So a lot of the discussion at the moment is around recycling and reusing. But there are opportunities, particularly around things like extending the lifespan of buildings and reusing building materials over and over again, creating building passports that can help in this transition to the circular economy. We also need to think about it from the context, of course, of the economic dimension. And so in the economic dimension, which is really what makes a business case to make things go around, we can start thinking about things like business models. So particularly the current global situation where we are constrained with global supply chains, what opportunities are there within our local areas to try and reuse materials as much as possible? The next slide, thanks. So when you're looking at it across the different stages of the building life cycle, it's starting with number one in the yellow here is really about promoting as much as possible the circularity of materials. But in a disaster situation, and depending on what the disastrous situation is, you may have opportunities to reuse building materials, but there are the social dimensions also that needs to be considered. For instance, taboos associated with the reuse of those materials. We also need to think about whether the materials are clean enough to be used. So thinking about it from the perspective of toxic materials or chemical impacts that may arise out of the use of these materials. So across the full chain of the building life cycle, where we start with design and construction and operation and deconstruction, we really need to start thinking about this as a holistic and a systemic approach rather than looking at different components of this approach. The next slide, thanks. So what are some of the things that are happening at a global level that are getting us to start thinking in this area and to support more and more work in the sustainability and circularity space? And this has happened through the building breakthroughs, where starting with COP21 way back in 2015, buildings and the built environment became part of the agenda for the discussions. And since then, a number of things have happened. And an example that is provided here is the development of the building breakthroughs that was started at COP26 in Glasgow and then officially launched at COP28, and looking at the priority action areas, which includes things like capacities and skill development, as well as creating a market in this space. The next slide, thanks. So some of the work that we have been doing in this space has been looking at how do we support the development of a circular built environment, and particularly in terms of the global south, because those are the regions that are being affected more and more with disasters. Next slide, thanks. And here is a great opportunity for us to start thinking about how do we expand, upscale, and replicate the work that we have been doing. And so what we have been doing is to try and increase the awareness and buy-in and build capacities and support a number of countries, particularly in the global south, in terms of both at a national level, at a local level, in terms of how do we continue to build and support this transition to circularity. The next slide, thanks. So some of the things that we have been doing has been looking at development of circular economy policies in this space. And we launched the 10 whole life cycle recommendations in 2024, and that was done as part of the Intergovernmental Council on Buildings and Climate, and through an extensive stakeholder engagement with over 100 professionals from over 40 countries. The next slide, thanks. We looked at circularity recommendations that were focusing, three of which were focusing exclusively on circularity, which is about prioritizing retrofitting, looking at how can we close a loop with material circularity, and how do we design for circularity. Next slide, thanks. So I want to focus a little bit. Can you take it to the next slide? I want to focus a little bit in ending on how policies make an impact. And there are two examples that I want to provide here. One is a Mediterranean Action Plan that is supporting the use of construction and demolition waste. And this is has been to help support the development of common regional guidelines that drive practical improvements in construction and demolition waste. And the final slide, if you can move to the next one, is looking at the recent changes to the Finnish Construction Act, where they're actually supporting the use of building materials and to demonstrate as part of the bill of quantities in the construction of new buildings to ensure that building materials that have already been reused in other parts, either of the same building or different buildings, can actually be used. So the policy context is a very important context for us to also think about. And I'll leave it there. Thanks. Over to you, Anita.
Thank you so much, Usha. That was wonderful, and definitely a lot of food for thought there. I just want to remind our participants, if you have any questions for our panelists or you'd like to contribute to the conversation, please feel free to use the Q&A section. And next, our last panelist is Martin Bjerregaard. I hope I got that kind of close, Martin. Thank you so much, and the floor is yours.
Thank you, Anita. Thank you, everyone, for joining wherever you are. I wish you all well. And I'm going to share on this webinar a little bit around some examples of the challenges that the building materials, the debris, the rubble poses in post-disaster and post-conflict. We've heard around the policies, we've heard around the initiatives to handle these building materials better. And to support that process, I want to share a bit about some of the practical elements of working with this building materials crisis. So I think it's important to understand the scale. We hear a lot about, and I'll later in the webinar share a bit about the millions of tons of debris. So we hear a lot about the huge quantities of debris that arise from disasters or conflicts. But really, the scale is relative, because if you look at the image to the bottom left here from outside of Mosul in Iraq, the damaged building from a family, the scale doesn't need to be millions of tons for it to be a real hindrance and a constraint on recovery. It's right down on the local level of each household. And on the right, you have recent photos from Gaza, where obviously the scale is immense and posing different challenges for the authorities. But scale is relative. And the key thing is that it's beyond the capacity of the building owners and local authorities to handle. And that's been the case the last decades. It goes beyond the capacity to remove with the resources that the local communities have. There's also a real challenge when you come into scale around where to start, because obviously some of these situations require 3, 5, 7, 10 years of effort. But where do you prioritize starting working with the building materials that are there? So prioritization is also a key factor. And then we need to put this building material somewhere. hopefully as storage for later recycling. But in some cases, yes, it will still need to be disposed of, the non-recyclables. And this requires huge quantities of land for storage, for setting up recycling sites, and ultimately for the non-recyclables to be disposed of. So scale, independent of scale, we still have these challenges. Now, within the building materials, we can call them debris, we can call them rubble. There are certain risks to managing it. So if we're not managing these building materials properly, because they contain hazards such as heavy metals, oils, chemicals, physical hazards as well from reinforcement bars, we have human health risks. And this is an everyday occurrence. If you talk to families, their children are in the streets and they are coming home with scratches, with cuts that can get infected. And we also have other chemicals within the debris. The debris and the rubble prevents access. So those returning to their homes, those returning to their communities after the disaster or the conflict, they can't get to some of the critical services. They can't get to the hospitals. They can't get to the water stations because of the debris creating barriers. And critical services can't get through. And you can't start recovery in a community if you still have debris lying everywhere. Now, if there's uncontrolled dumping, we heard from Missaka and Usha before as well, you know, we're having huge environmental negative impacts and liabilities from dumping this debris out into nature. And sometimes this happens on agricultural land. After the tsunami in Banda Aceh, we had to spend millions of dollars moving debris again because it was placed on shrimp farms and agricultural land in the haste of debris removal. So you are impacting on economic land value as well. You're also, in many countries, non-compliant to laws. Yes, after a disaster, you might have emergency measures, but some of these debris management, rubble management, building waste, building materials programs last for years when we've come out of an emergency law and we're into normal laws again. So we have compliance of laws and regulations, which is important. And key as well, which we'll be talking about later in the later webinars, but if we're not sorting and managing our building materials properly from the start, then we will have huge challenges in recycling it. Mixed rubble and mixed debris is super difficult to recycle if it still contains all of those contaminants and non-recyclables. And that starts with sorting it at the source. So we really have to think about these things right from day one. They are huge costs. Debris management is a huge cost to recovery. And if we don't attend to it properly, we're losing huge opportunities for not just cost reduction, but climate, environmental, social, and human benefits as well that can arise. Let's look at some of the hazards in the debris. Now, this is a bit scary maybe, but there are procedures, guidance, experience on how to manage all of these hazards. It's been developed over the last couple of decades at least. So yes, there are hazards. There's asbestos in a lot of the debris. There's asbestos in the debris in Gaza, in Ukraine, and other places as well. There's, after conflicts, you'll have explosive ordnance. You will have hazardous wastes and substances. That can be anything from under the sink in the kitchen, chemicals, bleaches. It can be from the local workshops. It can be from industrial processes as well, industrial hazardous chemicals. We also have human remains. It requires a dignified approach. There are procedures for managing that. You'll find snakes, scorpions, vermin within the debris. In Gaza at the moment, we have huge concerns around vermin. Rats are living in the debris as habitats and coming out and even attacking humans in the camps. A huge habitat for vermin and scorpions and snakes is in the debris. Structural instability with walls collapsed and buildings unstable, meaning that any sort of vibration or even any later tremors can lead to further collapse. And then solid waste. So solid waste, if you are a community, you've been struck by a disaster, you see a pile of debris, you don't know it's debris, you think it's waste, you'll put your own household solid waste on top of it. It's normal, it's understandable. But once we start mixing solid waste with building materials, again, becomes very difficult to handle. and to recycle and make the most of it. So I wanted to share two examples, current examples. Firstly is Ukraine. Latest studies from UNDP estimate around 11 to 12 million tons of debris across Ukraine. On a personal note, I think it's higher, but it's difficult at such a scale to across such a large region to estimate. But we're into the 11 to 12 million tons of debris at least. Now, key to Ukraine, very popular to use asbestos in the roofing cement, roofing sheets. More than 70% of buildings in Ukraine have asbestos in their construction building materials. So the debris, you could extrapolate 70% of that 11 million tons will also have asbestos in it. A huge challenge for a country that was using asbestos all the way up to only like 2 or 3 years ago, and where asbestos is not considered a risk because it's not on the profile. Open dumping is also a challenge, obviously, as you're trying to rebuild. There isn't the space, there isn't the facilities set up. They are starting to be, but not set up to receive this building material. And one of the key understandings for this is that Ukraine did not have any C&D, construction demolition waste, recycling or management systems before the invasion. So there was no experience with recycling C&D waste or building materials. That means we are working in an environment where there's a whole awareness raising and upskilling for debris, rubble, building materials management where there wasn't any before. Another recurrent example is in Gaza, nearly 60 million tons of debris. Now, Gaza is a very small place, and 60 million tons is unprecedented. It's globally unprecedented on such a small location. There's also limited plants, machinery, trucks, oil, engine oil. Just listening this morning with some colleagues in Gaza, the cost of engine oil at the moment is $700 to $800 per litre. $700 to $800 per litre for engine oil. You need the engine oil for your trucks, for your loaders, and for your excavators to move the building material. So you see, we're talking about building material management, but if we haven't got the oil or the fuel and we don't have the plant and machinery, there's not much we can do with the building material as a management strategy. So limited plants, machinery, trucks, everything in Gaza, and there's no land to place this debris on for storage in order to then come later and recycle it. So you see, the building materials, if we don't move this debris, we can't get on with recovery. But if we can't move it anywhere, then there's recovery. It's one of those games where you have your squares as a kid. You remember moving your squares around and you had to get them into location. We are really constrained in Gaza with building materials. And the quarries have run out as well, nearly. So this is a huge building materials challenge that we will be facing. And it's contaminated with explosive ordnance, hazardous waste, asbestos. And we also have, unfortunately, nearly 9,000 to 10,000 estimated human remains in the debris. So you can see we are globally faced with some huge building materials challenges. But again, back to the scale, these are the big ones. Building materials after post-disaster or post-conflict is ongoing all around the world, all over the place, unfortunately, to different levels, but it's still the challenge. Just one element on estimating debris quantities. Now, when we're talking about large-scale estimations, this UNEP methodology, and there are other methodologies as well, they are starting to become aligned across the board with World Bank, UNDP, UNEP, and the Quarry in New York. But you are able to now, using satellite imagery, achieve quite high-level estimations that are proving to be relatively accurate. And that's comparing satellite imagery pre and post the event, confirming the damage with, for example, nighttime lights and airstrike locations, and then using the database of those buildings to estimate height and volume. And then you can start to calculate the debris based on the total floor area, square meters damaged from the satellite imagery analysis. So we are getting quite good at the debris estimate. So when you see 57 million tons for Gaza, you see 11 million tons for Ukraine, the approach that has been taken to achieve those or to reach those estimations is getting more and more robust. So what I really wanted to put across today in this webinar is to for you to appreciate the problems, the challenges, but also understand that there are solutions, that there is experience out there. And we're seeing it, for example, in the UNOPS document just developed, the UNDP documents, the World Bank guidance. There is more and more experience coming through and being channeled into this sphere. And that's what we need to start picking up on and operationalizing. And that's hopefully in the next couple of webinars as well. Thank you very much. Over.
Thank you, Martin. That was great. I really appreciate you sharing those experiences with all of us. We have a few minutes now in our schedule for Q&A session. I know there were some pre-submitted questions that we're going to try to address, and we also have the Q&A function here in the Zoom. If people are reflecting on some of the presentations today and some of the discussions and have a question or comment, or if you want to share your experience, some of the challenges that you're facing, we can just have a bit of a conversation here. But I'd like to kick this off by turning to my colleague Missaka to put some questions to our panelists or address some of the pre-submitted questions. Over to you, Missaka.
Thanks, Anita. Actually, I would like to start by raising a couple of questions to Martin and Usha. Martin, first, I think you touched upon this issue in the presentation, but I think it will be useful for our viewers to understand better, because I also mentioned the importance, the current policy gap or the disconnect between the construction sector and disaster management and the acute lack of disaster preparedness in the construction sector. How can better debris management measures or policies, not only after disaster, but also before, in like having measures in place, procedures in place for construction, C&D waste management, how will that contribute towards better disaster recovery and better debris management post-disaster? Thank you.
C&D waste, debris, rubble are in essence all the same. They're just mixed in different ways and they're handled in different ways. But the processes, the skills, the knowledge, the plant machinery are relatively similar. So I've pushed a lot for the argument being to improve your C&D waste management, your building materials management, regardless, not in a normal times, to push for that. Not just because you would then be better prepared and able to be resilient to debris management once a disaster or a conflict, should it hopefully not happen, but it happens. But there are so many benefits to building materials, C&D waste improvements. You've got all the benefits that your first slide and Usha's first slide said. You're reducing your emissions, you're reducing raw materials extraction. Really key is jobs. The amount of jobs you can create in C&D waste management compared to just dumping it in a hole is huge. It's 6 to 8 times more. I mean, the statistics are 6 times more, but we're doing research at the moment. It's up to 8 times more jobs are created. So there's a blanket argument already. Improve C&D waste management, you'll create more jobs, more entrepreneurs, more business, more taxes. I mean, and what happens then is you obviously have the capability, if should it happen, there is a disaster or a conflict. So there are lots of justifications and reasons why you should be looking to improve C&D waste building materials management, regardless of a disaster or conflict.
Thank you very much, Martin. And I will there are a few questions now coming up in the Q&A. I would like to forward this question to Usha. It's again about recycling building materials, recycling rubble and debris, but more connected to the cost aspect of it. So I thought Usha would be better placed to understand, respond to this. It says, I wonder if there are any financial feasibility studies comparing the cost of recycling disaster rubble or debris against the production of new materials?
I think, Missaka, this really depends on the context, and I can tell you in the context of Australia, where the cost of first it was during the COVID period, and now because of the war in the Middle East, the cost of building and construction has gone up almost exponentially. And so if there are opportunities, and I go back to the point that Martin made, that if there are opportunities, if it is normal practice to reuse building materials in normal building and construction processes, then it is normal to then reuse these building materials at the time of a disaster. So if it is, it's really important to drive home that point, I think. And therefore, from the capacity building, the training, and the skills development side as well, it is really, really important to recognize that if it becomes normal practice to rebuild with materials that are already there, rather than having to keep building with new materials only, then we're actually not creating a generation of builders and decision makers that can see reuse of building materials as being normal practice. So I think it's really, really important point that Martin made that needs to be picked up. So yes, it's difficult to give a blanket answer without really understanding the context in terms of the financial cost.
Thanks, Usha. Before handing over to Anita, just being mindful of time as well, I would like to quickly highlight another question in the Q&A raised by Kusum. Actually, it's an extremely important point, the need to take these solutions to community level and actually make them available, accessible in a language that is more relatable to them. I completely agree with that. I think there had been certain initiatives where certain IEC materials and similar resources have been developed for sustainable reconstruction, but there is definitely a huge gap to fill in that, addressing the nuanced requirements at the community level and making it relatable to the communities. I would, Anita, do we have couple of minutes to check forward this question to Usha or Martin, or
yeah, quickly we could do
Yes.
that. And then I just want to say that for whatever questions we do not get to in the Q&A here or the pre-submitted questions, we will be drafting written responses to those questions and sharing that back with all the participants, as well as the resources that were shared today, and some copies of the slides. So we'll make sure you get the content, whether we get to all your questions or not, and invite you, of course, to come back for seminar 2 and 3, where we're going to dig deeper into some of these subject matters. So, but I do want to allow enough time for our colleague from Northwestern, Dr. Steve Carr, to offer some closing remarks. So if we can quickly get a response from Usha and Martin, and then we will start to wrap up. Thank you.
So as a quick response to you, Kusum, I would say yes, definitely. But often in a post-disaster situation, you want to create a shelter with whatever is available. And so, the post-disaster context is very much dependent on the preparedness that's associated to deal with that. So it's a long road, it's a long runway to help you get to understanding and surviving a post-disaster situation. Martin, I'll hand it over to you.
No, absolutely, Usha. The preparedness, I'm just thinking of debris preparedness plans we developed in Bangladesh for Dhaka, Sylhet, and Chittagong. And the key thing there was to get the private sector and the contractors involved, because they're the ones who are actually going to be doing this. So we really need to have them involved so that when something does happen, they can stand up and go, we know there's a debris preparedness plan. We helped develop it. We know what to do. We're going to start. Whereas some of the ministerial technocrats who were involved 10 years later aren't. The plan is on a shelf somewhere behind somebody on a desk. Nobody remembers except the private sector. They will remember. And they're the ones who are actually going to do this work. So they're the ones we need to motivate and to get involved. Thank you. Over.
Thank you, Martin. Great, rich discussion, but I would like to invite Dr. Carr to give us some closing remarks before we close at the top of the hour. Thank you, Steve. The floor is yours.
Okay. Let me just this is where I say to you all what we've just talked about and what it calls us to do. What we just talked about. First of all, we can do a lot better, and you've seen opportunities pointed out regularly over the last hour. Rubble is disposed of opportunistically as much as anything if you can find a place to put it. And reconstruction requires that you use materials, some of which have been greatly elevated in price because of supply and demand balance or imbalance. And the consequence of prices getting too high is people will simply go out and find wherever they can sand or lumber or clay, gravel, etc., water, to go ahead and do recovery. And that will leave the environment depleted indefinitely. We've been talking about global awareness, and part of what we're all about is to let everybody around the world know just the magnitude of what we're facing here and what has been going on forever. There are policy and technical opportunities, some of which are already being mobilized and some aren't. The third bullet here is stakeholder perspectives. In many cases, the people who are going to use the recovered structures haven't been consulted. And it would seem to me that if you want to get a good result in recovery, you should ask the stakeholders to participate. Existing policies are disaster driven, and sometimes they're unplanned, sometimes they're on the shelf, but not updated and so forth. Reconstruction strategies lack environmental safeguards. I've seen examples where environmental concerns are taken into account, but they haven't really been tested or experience has not been gained, and so opportunities still remain for environmental protection in the process of disaster recovery. There's a lot of technical capability around. We should use more of it, and coordinated governance is a way to make that happen. So preparedness in the construction sector is going to be a key to really moving forward rapidly. So my last slide here is post-disaster reconstruction represents an opportunity. And I put it that way because, there's a slogan about never let an opportunity slip through your fingers. But I've seen that turned around in an even more crafty way. Don't let a disaster slip through your fingers. In other words, a disaster is a way to get to new physical infrastructure you've been wanting to have all along. It's a way to get climate commitments really put in place rather than just talked about. We're looking at how to get circular construction practices implemented, and they have been emphasized over the last hour in many of the talks you've just heard. And finally, community resilience, meaning the ability to have persistence as you move forward, is something that needs to be added to disaster recovery. And so the last and bolded bullet is establishing a global hub for post-disaster building materials management is what would be the best thing to happen. And I hope you've been motivated by that from what we have been just talking about over the last hour. So with that, Anita, floor is yours, and I will stop my share.
Thank you, Steve. That's a great summary. Appreciate that. So I do want to thank all our panelists and guests and our partners in this conversation. We hope to continue the conversation with you in seminars 2 and 3. And of course, you can access the report as well as the other materials that were shared. Next slide. And with that, we want to say thank you. Please do stay in touch. Look for the invitations to the next seminars. Thank you for your engagement and your participation, and we hope to see you soon. And thank you again, once again, to our guest speakers today. Great job, and look forward to seeing you next time. Thank you. Bye-bye.
Thank you, Anita. Thank you all. Enjoyed that.
Thanks, everyone.
Thank you. Bye.
Thank you all. Bye.